Whew. I was getting ready and my computer froze, so I had to like start over a little bit here. So we should be getting folks watching. Let me know if I missed anything. Say hello on the Discord. You can join the Discord by going to the URL adafru.it/discord. That's the middle chat here, and then this is the YouTube chat. Hello, DCD. Hopefully you can hear and see me. Whew. Yeah, that was a little by the seat of my pants. That's why I'm a little late. I had like 5 minutes to go, and then I like froze up, and I was like, ah. So I had to hard turn off and start back up again. Hello, Cooper. Hello, Hams Labs. Sounds like it's going okay. So I guess I'll get started. Hello, everybody. My name is Scott. I go by tannewt online, and I work for Adafruit on CircuitPython. If you don't know what those things are, CircuitPython is a version of Python, which is a programming language really designed for beginners. Hello, Beata. It's great. Yeah, Python is great for beginners, and CircuitPython brings, leveraging MicroPython brings Python to little tiny computers called microcontrollers. Microcontrollers are little tiny computers that are embedded in everything usually. Adafruit makes, I'm looking for my board. So here's a relatively big one. This is not a board that Adafruit makes because the one that I have that Adafruit makes is all plugged in. But here's an example of a microcontroller in this chip here. And this board is not made by Adafruit, but Adafruit makes similar development kits for you to program and test and build things with microcontrollers. So if you want to support me and Adafruit, you go to adafruit.com, purchase hardware there. This is a deep dive. I do these every Friday at 2 p.m. Pacific. I was looking at my schedule. Next week will be my last week, and then I have 3 weeks off after that because Friday the 7th is a no daycare day. It's an in-service day, so I will not be working then. And then the following week, we leave on Tuesday to go to Japan for 10 days. So I'm missing 3 Fridays. Next Friday is my last one before I take a little break. And Foamy Guy is going to cover for those 3 times. So we're going to make sure Foamy Guy gets a fruit jam so that he can do some fruit jamming while I'm out too. Hi, Timon. So deep dives, 2 hours every Friday here, 2 p.m. Pacific. I love to answer questions. So if you have questions, like Cooper's got one here. Where are you heading in Japan? We're actually just staying in Tokyo. We have 2 young kids, so we're going to fly to Tokyo and then just stay in 2 different places in Tokyo there. What else? Yeah, so if you have questions, feel free to do that. Otherwise, deep dives are just whatever low-level stuff I've been working on. It's also a verb. Fruit jamming, I guess. Yeah, so we're excited about that. That's going to be good. And then I'll be around most of April, but then in May is when I start doing more paternity leave. So that's kind of my few-month timeline. So deep dives are usually about what I've been working on. And we have this board that is currently plugged in and wired up that I don't want to unplug to show you. It's called the Fruit Jam. Actually, I'll go to the desktop, and I think there's a web page I can pull up to show you it. Show you a picture of the prototype. So I will get my window going and then go desktop. This is my hidden one, so I'll just hide that a little more. And then here we'll go to adafruit.com. And on adafruit.com, you can hit what's new, and there's this Adafruit Fruit Jam Mini RP2350 computer. This is a prototype and a prototype name. Fruit Jam is not the final name, but I've got one of these prototypes, and we've been showing it off, and people wanted to sign up. So if you want to know when it's available, you can add your email here, and that will add you to a list of folks to be notified. They don't notify the entire list when things become available necessarily. If they put 200 in the shop, they'll do like 200 emails and then wait a little while before they continue down the list. And a super secret to this is that they can be put in the shop without sending the email. So if you really want to jump on it, the Discord is the place to be, and we may mention that it's available there before the emails go out. It's also how us Adafruiters can get things, like when they're going to be production stuff. We also can get prototypes, but sometimes new products, we just get a little bit of a head start. So there's a pro tip there. Okay, so what is the Fruit Jam? It is this board. It's got an RP2350 in the middle, and it's got 2 USB ports. So there's a USB hub chip here that is connected to the RP2350 and then connects to the 2 ports. There's a nice slide switch. There's this is the reset button, and then there's this button is the UF2 button, and then 2 extra buttons. This is for a speaker. And then this is line or headphone out. So there's an I2S DAC here. So I2S is a digital audio format. Which Discord channel mentions newly released products? It's not a particular channel. It's like if we find out CircuitPython dev has it, then maybe we'll put it there. Or yeah, basically if we know that you're interested, we can let you know. Also, sometimes they'll say in the live shows that things are available even before they actually are. Okay, so line out, headphone out. There's an HDMI connector for the DVI video, a USB-C port for USB device, SD card, which I haven't tested. This is an iSpy connector for displays, and then 5 NeoPixels along the edge here. So what I've been doing the last 2 weeks now has been getting CircuitPython running on here and making sure that everything is working well. Hi, ADCC. So I've been showing some demos. I'm in the weeds. Let me tell you, it's typical deep dive. We've had some problems with low speed devices working with this, and so I've taken it upon myself to try to fix it. And I have a working theory, and that it's that the timeouts for receiving a packet are not well timed. So there's like some super low level USB stuff that I need to get to because I need to commit it today and get it to TAC so that TAC doesn't duplicate work. But I thought I had this demo set up from yesterday, and I thought I'd show off that demo before I go breaking my build. Hi, Johnny. And yeah, if you have questions, let me know. Usually we don't answer a lot about unreleased products, but I mean, this is one that we're going to release. So I think we've been pretty open with what's here. It's all subject to change. It will move. Like, one piece of feedback that I've really had for Lady Ada is that the USB-C, HDMI, and the headphone connectors are all too close together. So yeah, HamsLab says, are you going to implement CircuitPython on the RP2040 at 200 megahertz? Is it just a recompile? Actually, you can speed up, you can set the CPU frequency on the RP2040 from CircuitPython code. It already works. You don't even need to recompile. You can do that. There is a huge caveat that you don't want to set up any of your peripherals before you do that. You want to do it super early, but then the like code that follows that should like read the current CPU speed and adjust for it. And in fact, this PIO host code is one of the things that is like being on different CPUs at different speeds. The PIO host code doesn't do well. So that's kind of what I'm fixing. Yeah, but so we introduced the ability to change the CPU frequency on the RP2040 along with the Pico DVI support on the RP2040 because the RP2040 needs to be overclocked for different pixel rates. So yeah, you can already do that on the RP2040. I don't know, ADCC would know whether that would work on the RP2350. But the RP2350, even at very similar megahertz speeds, runs a lot faster. We'll get into the USB timeout stuff in a little bit. I wanted to lead with the fun stuff first. So I've got a capture card here, and sorry, Linux likes to switch around which thing is on what. So this is the output from the Fruit Jam that I have going into a capture, USB capture thing. It's unhappy with my pull-ups, which I'm not sure why that is. So I'm just gonna hit restart and see if it comes up the second time. To be clear, 200 megahertz is officially supported now, so it's not overclocking. I didn't know that. Bob says it may work on the 2350. I hadn't looked at that. Whether it's called overclocking or not, it should still work. My pull-ups. I don't know why my pull-ups are. I'm going to unplug and replug it in. I haven't figured out. I've had this problem before. I don't know what it is. I don't know why sometimes my I2C doesn't work. It could be the DAC. I thought I had the DAC pin. Let me see if I can. Okay, let me get this. Sorry, I wanted to have time to do this, but I did not. Hi, Jono. Okay, and this one's a little misadjusted, but that's okay. There's a lot to do. Let's see if I can get the I2C bus happy. If I do, this is gonna still complain. But I don't have anything connected to it. But maybe if I do board.i2s reset, I think sometimes the let me just try to turn it off and back on again. Hey, okay. What would the CircuitPython instruction for 200 megahertz be? So if you look in docs.circuitpython.org, there is a processor object under microcontroller. So you can do microcontroller.cpu, and it's a processor object, and on the processor object is frequency, which is settable. It says on most boards frequency is read-only, but you can set it on the RP2040, some ESP32s, and some iNNexts. And on the RP2040, it will automatically adjust the voltage range as well. So microcontroller.cpu.frequency is the answer to that. And again, do it before you initialize other things. And then you can also read it to see what you're running at. Okay, so now I2C is happy, so let's do Control D and see what we get. Hey, okay, let me switch to the bigger one. So here's the demo that I showed on Show and Tell. And let's see if it works. I'm also going to turn on the audio. If I squeak, I'm sorry. The audio is a little bit weird, so I'm going to turn my monitoring on so I can hear it. Okay. The frame rate I don't think is, I don't know why it's that slow, but so this is the game that I've been working on for so I don't know if cgrover is watching, but I took their code and so this is Phil and Moore were like, there's no sound to this game that you've got. And so I was like, oh, wouldn't it be cool if it was like, I want it to be a little zen. So I was like, oh, what if it's wind chimes? So I took, and I was thinking, I knew that like cgrover had made wind chime code. So this takes cgrover's wind chime code, and for every plant that you plant, it is a particular tone of a wind chime, and then the more plants you have, the more likely it is that you get an audio from that. So I can plant different things, and the walking sound, I don't know if you noticed that I have a walking sound as well. It's like, I don't know why it's so slow on this, but it's actually working pretty well. I had some USB reliability issues too. So the walking sound is literally just like one wave of a sine wave. And there's like some squealing that happens when it starts up too, which is not great. So yeah, Cooper says overclocking has been a breeze on CircuitPython in my experience. It'll be interesting to see where RP2350 lands. Bob says it's microcontroller.cpu, I think it's plural, CPU 0.frequency. Timon speculates that RP2350 could actually be qualified up to 300 megahertz. Bob says each CPU has its own frequency and voltage setting, which I didn't realize. I thought they were the same. Anyway, so this is my Fruit Jam demo that I've been working on. And I guess what I should say also is that I'm using a NES-like gamepad. It's wireless. So I've just got this. It's like a 2.4 gigahertz wireless cheapy thing. Hi, Tyeth. Plugged into the USB ports here. I think the USB. So I have this keyboard as well. That if it should be working. I think, maybe not. Doesn't look like it is. I'm trying to control C the game and it's not working, so maybe not. But anyway, so these are both USB full speed devices, but there's full speed and low speed is not working. Cooper says, do you have a public repo for this demo, or are you planning on publishing it eventually? I'd love to see what it'll be like for programming for the Fruit Jam. I'll zip it up for you. In fact, I probably have it zipped up from yesterday. I'll just dump it here. I mean to put it on a repo. This is all just display IO. It's all display IO and just normal audio stuff. There's no, I mean, there's one, it's a new I2S codec, so there is that, but I'm happy to just send it to you. Let me see. Fruit Jam 2 from yesterday. Compress to a zip file. And here we go. Yeah, I mean to put it in a repo, but I haven't. There's not much more I don't think I want to do. I think what I want to do is I want to make, so like this is definitely inspired by it's definitely inspired by Stardew Valley, where you plant things and they grow. And I should also shout out the Sproutlands asset pack off itch, which is where I'm getting all the graphics. So you can see here, and it's pretty nice. I paid the $5 for the premium, which says that you can like use it commercially, which is nice. And I was like, okay, I could just do that. So this is me, Cup Nooble. This is your credit for the asset pack. There's lots of stuff in here. Actually, this is interesting that they have the dirt that way. I think that, I don't know. I was looking at that. They have the dirt here. Anyway, so that's what I was gonna, one thing I want to do is I want to get it nicely rounded. The dirt that I found was different. I wonder if it's an old tile set. So yeah, this is what I'm starting with, and I don't want to make a full game. I kind of want something like with no point, but just kind of zen. But I think the last thing I want to do is like change the speed that the plants grow, and then like make the dirt patches, not just square tiles. I like the wind chime thingy. I was also thinking about showing you what you're going to plant. But generally this is just a test. I want to do a lot of little games as tests for Fruit Jam and just actually just show it off. I don't want to do any like one big game. I want to do a lot of little ones. Like I want to do Snake. I want to do Snake as well. I'd like to do matching, so color, like where you flip two cards to see if they're the same, like that sort of game too. Yeah, so I'm able to use USB as long as it's full speed, not low speed. Is there any questions about that? Should I show the code? Actually, I could just show it. So it's not too much code. Don't crash, don't crash, don't crash. Let's see, it's 330 lines of code, a bunch of imports, Cedar Grove chime, set up the frame buffer at 360 by 200. So if I wanted to, I could just have that and do a chunkier version. How can we check if a device we have is high or low speed? Full or low speed. What you can do is you can do LSUSB on a particular device, assuming that you're on Linux. So say you want to look at my trackball, LSUSB -V, and then you can give it the vendor name. My Ploopy trackball. If you do the V verbose, at the top of that will be a negotiated speed. So full speed is 12 megabits per second, low speed is 1.5 megabits per second, and then high speed is 480 megabits per second. So yeah, that's how you could do it with Linux. Cooper says, once a good number of small games designed for the Fruit Jam are made, it would be great to have some kind of archive out there, or maybe a playground. Timon says it's very, very rare to encounter a low-speed device today. Well, let me tell you, I have some. I don't think it's as rare as you think when you're talking about HID devices. So here's like some random wired SNES kind of gamepad, and it's actually, you know what? Let me plug it in. I added labels. Low. So here's a low speed. I actually have this Apple keyboard to test too. So I don't know. I'm not convinced it's as rare as you think it is, Timon, because I've definitely had problems with it. I don't think so. I think you're being optimistic. One thing I was thinking about is doing I want to make code.py a launcher, I think, so that you can kind of like select different games and then kick out to different games and stuff. That's something I want to do too. Best practice for getting all the submodules in CircuitPython is to do make fetch submodules at the top level. The Raspberry Pi one is ginormous. They put like tons of files, but you can just do make fetch all submodules, and that makes sure that you don't clone everything. Can you show camera? Sorry. Oh yes, and the device mentioned desktop. This iNNext. Let me find a spare USB port. I will show you. I feel like it's a lot of, I don't actually know what's plugged into that, but oh well. Okay, so if I do ls USB again, and I think it's this GameRise pad. (0079) low speed, negotiated speed, low speed. And the problem is that right now, if you have a low speed device, PIO USB doesn't work, and it causes all of the other stuff to not work too. So it's bad. Yep. And the VID PID is this one. And it could be totally, it's like just some, you know, like Amazon special. So I've been reading up on how low speed and full speed devices interact and how they interact with hubs. And I'm pretty convinced that it doesn't work. It might work on its own, but it doesn't work kind of with other things. And it's labeled, let's see, it's labeled like iNNext, just off Amazon. So my brain's been in fixing low speed. Okay, so let me go over this code. Setting up, turning the DAC off and on, setting up the tone, so getting our I2S out going, getting the mixer going. We have to do 44.1 kilohertz right now because that's what the DAC init code is doing. It's just like test code. It's not like fully fledged at all. And then we're doing a sine wave, and now we're loading assets. So we have the characters, sprites, the grass sprites, the plant sprites, and the soil sprites. And those are different things. And then the tile width of the display and the tile height, then filling in the grass and then like making it nice around the edges. That's what this does. Adding soil. And then I actually do one tile grid per row of plants. So if we go to the overhead, I have to turn my controller back on. And now I'm in big mode. But if I plant, so this is corn. Corn is 2 tiles high. But now you can see that I'm behind it. When I first did the demo, the frame rate on OBS is not great. So if I I'm in front of it, and then at some point I go behind it. So the way that I'm doing that is every row of plants is its own tile grid. So like at some point the character gets inserted behind it. Yeah, this is an easier way to see. But yeah, I want to make the dirt patches, like, it just doesn't look quite as polished. So I'd love the dirt patches to look just a little bit nicer. And because the screen is smaller, we're actually getting more chimes. We don't have as many blank spaces, so the chimes are going to hit more often. But thanks to cgrover for those. Right, yeah, ancient ICs that are used in HID devices. Yep, exactly. I think that's where you're finding it. Okay. Yeah, or bad firmware. Okay, I'll leave the chimes going. Is there a release date? No, there's not. It is also not an RP2040, it is an RP2350. Part of the work that I'm doing now is validating that the hardware is right, and that's like a prerequisite to doing a larger batch. Okay, so one tile grid per plant row, and they're too high just for the corn in case you plant corn there. And here you can see the layers. We do the grass, the soil. We keep track of the first plant, and we start in the back, and then we do plant rows. We find my gamepad. It's just hard-coded right now, and the VID and PID look a little suspect to me, but whatever. I detach the kernel driver, and then I have this gamepad state thing. So these are two quick data descriptors. So it allows you to say, hey, for this given buffer, here's how you access like A, B, X, Y, L, R are these bits in this. So which byte and which bit. Start and select are in the second bit, and then axes are up, down, left, right, which byte and what value. And then get gamepad state. So, another thing I'd like to do in this game, I want to keep it simple, but here's more stuff I want to do. I also want to add a second player because there's two USB plugs in the front. I would like two people, although I was thinking about, I wonder if I meant to look in the asset pack, but the second player doesn't have to be the like thing that walks around. It could be maybe a cat or a cow or a chicken or something. Like it could be some other thing. Could be kind of fun. Although there's only animations for like the first character. So yeah, I would like to make the dirt look good. I'd like to add a second player. But yeah, besides that, I don't want to do too much more. Okay, so here's some state or not state, X and Y changes, current speed, current seed that you're going to plant. Idle delay, I'm not sure I'm using anymore. Which way are you facing? Where in the animation cycle are you? Which action are you doing and when did it start? The target tile is the one that which one are you facing? Frame number is just counting, and whether you're in the menu, in menu I actually got rid of. It was too complicated. So you get the gamepad state. So this is on a single frame. And then depending on which buttons are pressed or which way are you facing. If you're moving, then we play the sine wave sample. Should it be expected for an exception to be raised if user code calls device read and passes the buffer that's smaller than the amount of... I was doing that accidentally first and I was getting a lot of hard fault memory errors. No, we shouldn't ever hard fault. But there's definitely flaky problems in USB host. So like, yeah, we should fix those. And I think that's a lot of the work that I'm going to be doing and TAC is doing. And and Jeff as well, of like just making sure that the USB host stuff is solid. And I'm like super excited that we're working on this again, and we have a device that we need to make sure USB host is good for. But yeah, it should never hard fault. Should never hard fault. Easier said than done. You can hold R if you want to run. If you're moving and you're not in the middle of an action, then you count is how you kind of decide where in the animation cycle you are. If you're running, then you're doing further down in the animation, in the character's animation sprite sheet. Otherwise you're going faster. Otherwise you're just running. And then offset 0 is idle. If action start is none, then we have a target tile. We figure out if you're pressing A, B, X, or Y. So B is to do the hoe. X is well, like there's chop and water. And then Y is Y is to plant. So you plant the current seed in the target tile, and we strike the chime that the plant represents. Select allows you to do a new seed, and it bumps the frame number. I haven't figured out how to show what that is yet. Have you tried file access over USB much? Set up your game to load off as a ROM, a USB be a heck of a test setup. Set up your game to load as a ROM off of USB. Not exactly sure what you mean. File access over USB. I'm not sure what you mean, Tyeth. If you're in the middle of an action, how far in the action are you? If you're 24 frames in and you're doing the hoe, then you change the state of that to, so this is like setting it to dirt, and then stopping the action, and then you stop the action. Otherwise you increment your count to go through the animation. If you're not moving, then you also do the idle animation. How do I listen to FM radio stations on SDR? I do not know that, I'm sorry. I've not done a lot of SDR. CircuitPython was an emulator. The ROM was the game application stored on a USB, on a USB stick. I haven't tried the mass storage stuff yet. I have USB host code. I have USB host code for mass storage, but I've heard that it doesn't work. Okay, so character 0 is what tile are you showing? Character X is where it is. Last Y is where it is vertically on the screen. And then you compute the depth, and if the depth is changing, you remove the character and insert it back into the stack of things. And then we do a loop. Every 6 frames we update the plants. So we go through all of the cells, figured out if there's a plant, if it's been planted, and then grow it. And then lastly, we hit a random cell every frame. This is the chimes. So like if X and Y are, sorry, that was my Discord. Changed RP2040 to 200 megahertz. Great. I'm glad it worked. Yeah, so it picks a random XY coordinate to strike, and then if there's a plant there, it calls the chime.strike from Cedar Grove stuff. So, and then it increments the frame number, and display.refresh, because it's given a target frames per second and auto refresh is off, it will actually delay until, like, it tries to keep this loop going at a 30 frames per second pace. So yeah, that's my gardening game. Oh, and I saved it, so it restarted. Any questions about that, or should we get in the USB weeds? corn and pumpkins. I don't know why the frame rate on, at least on my OBS, the frame rate's not that great. I don't know if the frame rate looks bad to you, but on the TV, it usually looks like pretty smooth. Oh, and it saved again. What would it take to run on the PyPortal? It should run. You're gonna have to figure out how to get change how you do inputs. I actually have a version. I have a version that uses standard in to do it as well, but I haven't factored it out. This game is on the RP2350 at stock speeds. So the Fruit Jam is the RP2350 running at what, 150 megahertz? One of the tricks with display IO is that it's pretty quick as long as you're not updating all of the pixels in every frame. So like the fact that the character is moving is like not too bad, but if you were like changing every pixel on the whole thing, it'd be a lot more difficult. DCD says, USB question, were you making further use of the Great Scott Gadgets USB analyzer? I was having trouble. I haven't been using it very much. And I think actually like it has a drop down for whether you're doing low speed or full speed. And like, because of that, it won't be very good for debugging the low speed stuff, because maybe it's time to switch to USB. And let me just plug, if you're doing USB, you should have this book. I like literally sat on the couch in the office here and read this book to figure out how it works. So, how many plants can you plant in 20 seconds, frame rate as they all grow? So they grow in 3 seconds right now. And they should, yeah, like, I guess I've never planted every spot because I just haven't, like the auto reload catches it. I showed a video to my kid of this and he was like, I want to play this game. And that's why I want to do 2-player, because I want to be able to play it with him. Oh, that's the pumpkin. There actually are more spots off screen too. I kind of like the wind chime thing. Thank you, cgrover, for open sourcing your code. I also like that you walk behind the plants now too. It makes it look way more like real. But yeah, the dirt things are a little less than ideal. Yeah, so this is CircuitPython running on the RP2350. It is using HSTX to output DVI at 720 by 400, although the frame buffer that CircuitPython is doing is only 180 by 100, and then it's quadrupled to the output format. And I actually added the ability, there's a PR out for the Fruit Jam, and in that PR I improved Pico DVI to be able to do that 720 by 400 and all of the quadrupling, and I made it work with 32-bit color, which is a dummy byte, but you can actually get like 8 bits RGB output. It just quadruples or doubles it, which is kind of neat. Is the low-speed device issue mostly that it crashes things at the moment? So I did have one issue where I was hanging Like I pulled the USB device out and then the host just hung forever. So I'm trying to fix that. And then I also had an issue. There's just like PIO USB is not following the like timeout stuff. So it's like the low speed device is talking when it shouldn't and things like that, I think. What is your best resolution that can fit 128 by 128 by Pico 8? So I think it might actually be a quarter of 640 by 480 because it's 120. So you lose only 8 pixels vertically if you do quadrupled or whatever 640 by 480 divided by 4 is. So that's probably closest. You only lose 8 pixels then. But then again, I'm also not trying to be quite Pico 8. I do have the Celeste demo, and now that I have gamepads kind of working, I do want to switch that too. Yes, PIO USB has low speed support. I think the crux of it is that it doesn't do timeouts correctly. So let's just stop this chime nonsense. If folks have more questions about the demo, I'll leave it running until I test my USB code, and then no promises. But I'll even take this off. I don't need to listen to chimes, and I'll turn the chimes off for you too. Okay, so let's get into the weeds, as I like to do. So I'm gonna, I'm just gonna capture this again. And you can't see my desktop, so I will switch to the desktop. So I just have this like random backups folder. '20, 25, 02, 21, Fruit Jam. Paste. I was actually playing around with like the tiled map editor as well, which maybe I should just show real quick, because I think it will load up. Yeah. So this is pretty neat. So it allows you to like place tiles, and it has a terrain mode, so you can say like, oh, I want to place grass, and then you just draw like where you want the grass, and it picks from the right tiles to like make it nice. So I was talking with Foamy Guy about adding support for this, so that you could like load levels and stuff, but I don't think I'll do that for the gardening game. But like, yeah, when you do the hoe, make the grass around it nice, I guess. So that was kind of neat. And this tiled editor can also be used for like platformers and stuff too, which I think we should also have a simple platformer game as well that then you can use tiled to make things for. Okay. I don't need this stuff. So, low speed. I guess I'll just show it with my diff of what I've been doing. So if we look at the diff, I'm now keeping track of whether we're in low speed or high speed mode. So low speed or full speed mode, sorry. Gotta be precise. There's this PIO USB wait handshake, and it has this timeout where it's just t equals 240, and then it subtracts t. And this might work if you're like running on RRP 2040 and and you're not overclocking. But the moment that you are overclocking, like your time skews, and you're going to think that you timed out when you didn't. You just didn't wait long enough. So this is a PIO USB bus wait handshake. So this is the waiting for an ACK or a NACK from the other side. This code is shared between device and host. So it's waiting for an ACK or a NACK from the other side, and that's 2 bytes worth or tokens worth. So once it gets 2, it considers it's done. If it didn't time out, then it waits for this, like, there's an end of packet detection that sets this RX complete flag as well. And then it returns just the handshake that it got. The problem with this is that because the timing is based on subtraction, that like if you do any sort of overclocking or you're just on the RP2350, like you're not actually going to give yourself long enough to wait, especially if you're doing a low speed transaction, because low speed transactions take longer. Yeah, and that's what Timon says, is that if it's just waiting for cycles, that would blow up very quickly at any other clock speed. Exactly, right? And it's not accounting for like time, whether it's timing out a full or a low speed transaction as well. Okay, so Tyeth has a question. Just remembered, got a question for the CircuitPython USB wizard. I only just discovered that the M4s have some examples that use a dual write access for the CircuitPy drive. Presumably it's just turning on or off some lock, as I've seen some tinyusb callbacks in the example for dual access in CLAN. So does ESP32, etc. also support that, and is it semi-reliable but may cause complete file loss occasionally? So yes, so CircuitPython tries to protect you from having both CircuitPython and the USB host accessing the bytes of the file system at the same time. And there is a thing that you can do in the boot.py to prevent that from happening. But I really wouldn't, because you have 2 things that are trying to manipulate the bytes of the file system at the same time, and you need to make sure that they're always reading before they manipulate it, which is not, like, host OSs are not assuming that the file system is going to change underneath them. In fact, even if your file system is read-only to the host OS, like, it caches stuff. So like even if you're manipulating it as it's connected to the host OS, like the host OS may not see it because it's cached data. It's not designed for that. DCD points out that the make fetch all submodules is the way to go. Yeah, it's the Raspberry Pi thing. It sucks. But the repo that we use for that it's got like a bunch of kernel images in it or something. Yeah, that's why we had to do that. You can do the raw git submodule within the particular port directory that you're in, but don't do it at the top level. Yeah, the example only stored a cache.bmp on the drive, so the host would be accessing code, not the CircuitPython device. You still have to worry about the like fat file system metadata between the two. So even if it's a different file, like maybe if the file exists already and you don't change the size more than a sector's worth, it's okay. But any sort of manipulation there, that's going to be trouble. In fact, one thing that we've talked about doing for the Fruit Jam is actually doing 2 partitions. One partition for CircuitPython writability and one for external. So I was thinking about adding the ability to have like a saves directory. So it would be root/saves. And then in there is like what's writable from CircuitPython. And it would be read-only to the host OS if we had a second thing. But we probably won't. Someone says, should it be fixable if you make it CPU clock dependent cycle await, I guess. Yes, that is my plan. So in CircuitPython, what we do is, let me show the CircuitPython code. So what we do in CircuitPython is we set up the SysTick for the CPU core to do a load value that is the processor frequency divided by 1,000. So this is basically we use SysTick to time a millisecond for every frame of the USB, which has this added benefit that like at the start of a frame, the timer is high, and by the time at the end of the frame, it's low. And so you know that SysTick is just going to count down between those two things at processor frequency. Although I was meaning to check because SysTick is only 24 bits. So 1 to the 24 is still 16 million, which is fine because that would be times 1,000. Oh, the Python limit is 4,300 digits. Right, so let's see. This would be 16 gigahertz in order to do that. Yeah, so I don't know if Arduino has SysTick set up like this, but they can set it up like that. And even if they're using it for something else, it's probably running at CPU speed and still counting down. It would only need to worry about wrapping that 24-bit value. But because in CircuitPython, the SysTick is used for frame timing, and we can also know that we're not going to wrap. For all of our timeouts are happening in the middle of a USB frame. They're not going to span USB frames. So it's kind of a neat thing that like in CircuitPython we can use SysTick because it's just literally counting like where we are in the CPU in the USB frame, which is cool, and it's like great for timing timeouts. Yeah, we just need to like look at the Earl Philhauer core and see how they have SysTick set up, but Jeff has been doing that work, so that's fine. So yeah, see, so we set up SysTick. We also set up in CircuitPython, we set the MPU so that this core is not allowed to use code that's in Flash, which is a huge source of bugs, unfortunately. So like, if your USB host just stopped working, like this is probably why. Like you went down some path where it called code in Flash, and instead of letting it do that, because this is on the second core, the first core could be turning off itself so that it could do flash writes, and so you don't want the second core coming in and doing flash writes. Yeah, so we set up SysTick, and then we turn off execution access to anything but RAM. And then we do a while true loop where we'd say, hey, we're going to do a host frame. We see if we have any tasks to do, and then we do a background schedule, which should tell, and I meant to check this, it should tell the other core to like run the tinyusb stuff, and then we just busy wait that core until the SysTick timer goes off, which is probably less power efficient than we could. We could probably actually wait until something. I don't know how SysTick can wake us up. And in fact, SysTick might go to sleep when we go to sleep. Anyway, it doesn't matter. We could change that if we cared. We're plugged in. We don't care about the power that busy waiting is going to cost us. But yeah, so we just wait till it wraps around. And then we start the frame again. So my code that I have not tested yet. So there's both this bus wait handshake, and now there's also bus receive packet and handshake. So this is you're receiving data and you have to reply back with the handshake. And it was doing something very similar. It's kind of hard to see. I wonder if I just make this window bigger, it'll show you what the original code is. So it's setting up the CRC stuff, and it's got t equals 240 as well. And it's also got this knack timeout, which is set to 10,000. So it's doing hey, while t is like greater than 0, we're waiting until we get 2 bytes. So this is waiting for, it's a sync byte, and the PID byte, the PID token, the packet ID. And then if we're going to ACK it, we wait for the end of the packet. We make sure that we haven't overfilled our RX buffer, and we compute the CRC, and we load it into the data buffer that we've got. And then after that, we say, hey, are we matching the CRC? And do we care? And if we are, then we give this ACK. Otherwise, if we're potentially not ACKing anyway, we just discard everything, clear the FIFOs, and then send the handshake that is not an ACK. So it only runs the CRC computation when it's potentially going to ACK, but I don't think you're supposed to knack if the CRC is wrong, because you want them to send it again. So what I was doing right before this is I'm unifying it. So like this is a busy wait anyway, so why not do the CRC computation? It's kind of where I'm at. So I've added this new PIO bus wait packet, because that's really what we're doing. We're just waiting for a single packet. It's a like waiting for the start to happen. We receive all the data. We receive an end of packet, and at any point that can time out because like you've unplugged it. So it's like you got to be very particular. Like, and then the other thing about USB at this level is that if the CRC fails, you don't send any handshake back. And the only way that you know there's no handshake is if you've waited long enough, right? It's like, it's timeout based. So it turns out, I think the timing for this is critical. Oh yeah, you can't see the other side. Thank you. I will pull it up in my thing instead. No, I don't think so. The PIO USB. So here's the new function that I've got. It is PIO USB wait packet. It sets up the CRC stuff. It gets the RX buffer, which is like just fixed. And now we're doing ticks per bit. So if we're low speed, I've previously computed how many SysTick ticks are per low speed bit and full speed bit. And then the bits to wait actually varies as well. So hosts wait at least 18-bit times. Devices wait at most. They're supposed to time out before 18. So that's why bits to wait. And now there's this notion of whether you're the host or not. And then you just say like packet start. So it says from the end of the packet, from the previous EOP to the start of the next one, which I'm not actually timing because I don't know exactly how this function gets called relative to the end of the packet that I've done. But I basically like taking the value and I'm subtracting the number of bits to wait times the ticks per bit. And then I say like, okay, while we're above that, if the reception has started, then we break and the timeout doesn't apply. And again, we check here. So if we finish the while loop and we still haven't started, then we've timed out and we've returned 0. And like the thing that's higher level can retry again. Otherwise, now we have a token timeout. So we're just waiting. Okay, we're going to get a byte of data. We're going to get a byte of data. We're going to get a byte of data. And I'm like, okay, let's wait 10 bit lengths. So 10 ticks per bit. And ticks per bit is for the particular speed. So this is saying like, okay, we're going to wait. We're going to time out like this much longer, this much longer, this much longer. And then if we get a value into the RX FIFO, we'll read it. We increment our index. If we're less than the RX buffer size, we'll put it in our RX buffer. We'll set our new token timeout. And then if the index is greater than 2, we'll do the CRC. So the previous code had like one reception for the first 2 bytes. And then later on, if it was going to ACK it, it would do the CRC stuff. We'll never get here. We'll never get here with the just waiting for a handshake code because We also have this else if that says, hey, if Rx is complete, then we're done and we break. So we either time out or we're complete. We don't know how much data we're receiving. We just know like the maximum that we can store in our buffer. And I just made a note that like, yeah, there's a chance that like there's two PIOs that are running. One that's detecting edges and end of packet. And there's a chance that like the decoder that got the edge doesn't quite finish as fast as like the end of packet detection, but I don't think that's going to be too big of a deal. But I added a note. There might actually be a race of like where there's like one final byte that we have to get out of the RX FIFO, but it's not handled in the current code either. And then we say, okay, once we're done with that, we're going to time out waiting for one more packet. Maybe we don't need to do this. You know, we probably don't need to do this. This is a relic of... I don't think we need this. Because we're not stopping here until we actually get end of packet or we've timed out. So I don't think we need this. This is a relic of the first version where it was, I knew I was getting 2 and then I could do that. I have a Beagle that I can do captures with too. I got it covered. And then if we say, oh, if we've received 4 or more bytes, we check the CRC. And if it fails, if it doesn't match, then we return 0. So we basically pretend that nothing showed up, which is fine. So yeah, I don't think we need the other one. So now our 2 versions have been unified. We have a bus wait handshake. So this is waiting. Oh, and if the CRC does match or it's less than 2, then we just return that. It's okay. So this should wait for 2 packets. So a handshake should be a sync packet, the like NAC, ACK, or stall, and then an end of packet. So if it's right, it should be too long. And in fact, we could be even stricter. We could say if it's not 2, something's bad. For waiting for the handshake. And then this is a receive packet and handshake. So we wait for the packet, we get the length. If it's 0, that means the CRC failed or it never came. And we return that -1 means it didn't work. Otherwise, we send the handshake that we wanted. So here we're not doing different behavior depending on whether it's an ACK or a NAC. We're still checking the CRC. There is actually there's supposed to be like a 2 delay or 2 bit times. So the bus can turn around. Or no, we're receiving and we're handshaking, so we don't need the delay. But if you're handshaking, yeah. Anyway. I don't think so. Tyeth asks, can index be 3 at the end of the function above? So I don't think so, because for anything that's 2 or more, you're going to have a CRC. So I think that's what it is that it's like you either get 2 or you get 4 or more because of CRC, I think. I don't know that for sure. Let me look in my book. This book is just great for this. And it has like USB 3 stuff in it too. But I'm not even doing high speed. I'm just doing low and full speed. But yeah, so here's this diagram there. And so we're talking at this like token packet, data packet, handshake packet level. So yeah, I guess if it's a data packet, it's a PID, the data, and the CRC. If it's a token packet, it's the PID, address, endpoint, and CRC. If it's a handshake packet, it's a PID, but it's actually, there's also a sync packet that goes below. This is page 41 of the book. Page 41 if you're following along. Supermath did the math. If you want to output a 128 by 128 frame buffer over DVI using HSTX, I believe the lowest resolution that would only have a single pair of pillar boxes and doesn't cut off any pixels would be XGA at 1024 by 768 pixel sextupled. Though I'm curious if the RP2350 can even handle that large of an output. So the constraint on what you can output is actually the pixel clock currently, because I'm not overclocking at all. Hold on, I'm going to mute while I sneeze. I think I have to sneeze again. All right, hopefully it's only 2 sneezes. Yeah, so CVT can do 1024, 768 at 30 is a pixel clock of 30 megahertz, which actually might work. I bet we could do that, actually. 1024 by 768 at 30 megahertz. So we're also doing, so CVT, what gives you the timing? Now, whether your display supports it or not is a separate question. I should look at that. So what I was doing is I was taking displays, like I bought this TV from, I bought the TV from Goodwill as a test TV. I should look more closely at all the modes that it shows up there. Because we're kind of wanting to shoot for a pixel clock about 25, I think is what it's set up to be. 25 megahertz. So if we do like we're doing CVT 640, 480 at 60 is 23.75 megahertz, and then 720 by 400 at, it's actually 70 megahertz, is 26.25. And I think our pixel clock is actually running at 25. But these both kind of work. And then, but like 30 megahertz, I think that's doable too. But yeah, so the limit is kind of like that pixel clock and what you can generate. So the HSTX runs can do double data rate. So if your HSTX is running at 150, your pixel clock is 300 megahertz, and then pixel clocks are per pixel, and it's 10 bits per pixel. So your pixel runs, if it's 300 megahertz, your pixel clock is, if you're 300 megahertz dual data rate, your pixel clock is 30 megahertz, like divided by 10, I think, because it's 8 bits of data encoded in 10 bits of on the wire. TMDS is 10 bits long for 8 bits of data, I think. So yeah, 1024 by 768 might actually work. I'm like quite curious because I'd love to find resolutions that kind of fit that bill. So yeah, maybe. Should we see if this compiles? I just went over it and it seems reasonable to me. So let's see if I can't get it going. And I'm all messed up because I'm ports. Oh, Zephyr port. Make debug clean. you think it's going to build? How wild would that be? Nope. No previous prototype. Huh. Assignment of member in read-only object. Oh, okay. Darn. I mean, I can change that. PIO USB host. I think. Oh, come on. PP here. Yeah, so it's not read-only here. Okay, PIO USB 47. This is going to be kind of annoying, but I think it's good. It's good to keep track of the state of the bus. And then USB transfer. It's kind of annoying, but it's changing the state of the bus. Send token. Okay. Okay, it's not const there either. I think receive packet and handshake. It is const. I don't know. I don't care about it. Send token. Needs it const as well. Send handshake. No previous prototype. Oh, I think I can make it static. That should be fine. Now I just need to remember how to PIO USB. This is probably Copilot autocomplete thwarting me. Okay, so now I just got to figure out how to use SysTick, which shouldn't be too bad. Let's see what we have. That's in PIO USB. And it's doing Pico stuff. And how do I do it in port? I have too many files open. port open here? There it is. So we are including SimSys. Darn. What is the Pico SDK way of SysTick? I don't really want to do it that way. Oh. Pico C examples. No. RPI, how do they include it here? Hardware structs SysTick. Oh. Ah, okay. Structs. Only has one tick generator. Yeah, I'm not using that. Part of the watchdog hardware. I think these are the 1 microsecond ticks, not the SysTick. Yeah, these are the microsecond level. Ticks generated from the tick block. I don't think that's what I want. So SysTick is a feature of like the ARM cores. I think I'd rather do that. Init SysTick. Is that in Pico SDK? We let it free run. Okay, that's your own, I think. Okay, so if I do hardware struct SysTick, I should have it. In PIO USB. Hardware structs SysTick. And then SysTick val. Val becomes that. Is that what it is? No. CVR. I don't think I want that. I don't think I want tick start. It's not the tick you're thinking of. It's not the tick you think you're doing. All right, how do I get the system core clock and Pico SDK? That's the other question. This might have it. F clock sys. Measure frequencies. Clock get hertz. Copy link. Good, I'm glad it's free. I'm using it. I'm going to use it. And 357. BIO USB 357. I think system core clock should be what I want, but ADCC said that each core could be clocked differently, but I'm not sure. Like I said, it's an ARM thing. Do any other CP/ARM processors access it? We used to use it. We used to use it for other things. But the nice thing here is that like we're only running USB host on the core right now. So it's okay. Right now we can use it. We're the only code running. I mean, the PIO USB host is the only code running. Core clock hertz. I didn't think, you know what? Switch to tab. That is in my other browser, but that's okay. I thought they were on the same clock. Am I wrong? Processors, memory, boot ROM, power, resets, clocks. Clock sys goes to the processors, the bus fabric, memories, and memory map registers. So the cores can't go different speeds. It's per core? SysTick is per core. SysTick is per core, but not clock sys, not the clock speed. Clock sys is shared. Clock handle. Select clock sys. Clock destination. Enumerator. Check. Set sysclock. Can I get sysclock? I need a clock handle. Why is this so hard? I don't have a clock handle. Maybe I really do need to just do the arm thing. Like, this is a SimSys thing that should be. Oh, just clock sys, huh? Pound include core clocks. Copy. Hardware clocks. Okay. Let's see if that works. John was sending me links to the hardware clocks documentation. Hey, it worked. Okay. Do you think USB will work if I reload it? Hi, Anne. Thanks for stopping by. Anne runs our newsletter and blogs a lot of stuff. Huh. Okay. Let's copy the firmware over and see what happens. We'll switch to debug. Hopefully it comes up. It's possible it won't even start. Oh, but it does. Good. Let's split this top to bottom. I don't know where we're at. I think do I have HSTX working? No. No, it's not showing anything, huh? Huh. Oh, you know what? I had this problem when my USB failed. I do actually have USB output to debugging output, I think is going still. And I'm going to eject. It should still work. Famous last words. I'm not doing low speed right now. Oh, let me go back to the desktop. It's so imprecise. No, there's no a gap. I didn't get any USB output. Should I get USB output? I feel like I should. Let me, the other thing I could do is, I'm going to see if the core 1 has crashed, which will happen if it calls flash code. Repos, openocd. So I'm starting openocd, talking to the second core. And now I can do this and go backtrace, and it's fine. Port line 72. Should be fine. But nothing is happening on the host side of things. This is the annoying part. How do I debug this? Like I can restart core 1, but not core 0 at the same time. Like redoing both cores at the same time is a pain. Let me double check that I have tinyusb debugging on. I do. Yet I'm not getting any output. If I hit reset. Yeah, I know. Did I disconnect my... Oh, I did. my pile of stuff. All these wires and things has unplugged my serial receiver. Okay, well this one's ground. And I can't remember which one's RX and which one's TX. So let's plug them back in. Hit reset. And we don't get any output. So I'm going to flip them. Very scientific. Okay, and then I'm going to hit reset again. There we go. All right, so it did something. First, that it changes to the time I'm actually doing what expected. USB host device attached, full speed, get descriptor, control failed. So this is where I import. I actually do this. I get rid of that, and now I can print debugging from PIO USB. Packet. Maybe we're not waiting long enough still. Or start mask is never actually set. Console. This doesn't have any logging in it, does it? No, I don't think it does. Maybe we need to do a tlog here. Where did I put it? Ah, that's fine. I'll do that here. See if that compiles. Implicit declaration. I think it's in what? Supervisor serial shared serial.h. That's what it is. All right. Shadows global. Lovely. Lovely, lovely, lovely. I gotta go use the bathroom. I'll be right back. Let me go to window cam. I'll be right back. right, thanks for hanging with me. One challenge with doing the Beagle in the loop is that the plus and minus are broken out between, that goes between the 2350 and the hub, but like I can't, like the Beagle usually has like 2 plugs that you do, like, and you put it in the middle. I can't actually put it in the middle here. 439. I'll just temporarily change the name of this. Oh, byte. The type A on the fruit gem is downstream of the hub. It's a downstream port on the hub chip. All right, and I'm failing to talk to the hub chip at all, so. Are we getting to that code at all? Did I break something else? We should be getting there. Yep, it's got the CH334 on it. This is going to slow it down. I just want to see if we're getting there. I really don't like that in KDE when it pops up the drive, there's a USB hub between the 2350 and the device. Yes. The 2 USB-A ports are on a hub that's on the board. Here's a USB bus packet, okay. Interesting. It worked. It worked with the delay. At least a little bit. Device attached, full speed, get descriptor. When previously get descriptor failed. Why did it fail before? I'd love to be able to say, I wonder if this is the I bet there, I wonder if this is the, like, we're not doing enough. Like, we're missing. I wonder if this is the race that I was worried about. Or I'm assuming that I wonder if my interpacket timeout is happening. Let's do this. I wonder if this is just too slow. I wonder if we should still be waiting. I don't know how long of a gap we can expect between things. Data byte timeout. I want to invert that. Okay, just about done. I bet there's an RP2350 Metro in the office. Whose office? I have one here. Oh yeah. Wire up a type A on another USB board for testing. Yeah, I could. You're right, I could. I even have like a RP2350. I guess we don't have a 2350 with a USB host A on it, do we? That's true. Yeah, that's a good step for Monday. If I can't figure it out. Huh. Weird. It's saying it failed. Is that because USB host in transaction? Data mismatch. Receive length. I guess this isn't in. I do have Metros here. You're right. And I think I have the USB host chip somewhere too. I just gotta find it. But I don't. Yeah, I gotta find it, and then solder it somewhere. It's a task for Monday. But you're right. Yes. If I can't magically figure out what the problem is. Like, I should probably be in tinyusb where this failed is coming from. Like, I just wonder if, like, the length is wrong. Like, descriptor, and I'm returning the wrong number of bytes or something. Control failed, retrying. Like, if I just look for retrying. Okay, USB h.c. Hey, look. Failed. Transfer result failed. transfer callback. Where is this coming from? Probably source portable PIO USB. HCD PIO USB. Transfer failed. At some point, I'm suspecting that my code is returning the wrong length, because if I think I'm erroring out, then it says that yeah. Handle transfer complete. So 239. Connection check. Endpoint failed count. In transaction. It is an in transaction. Greater than or equal to 0. I'm gonna have to push these changes. Does the Max 3421E or a USB host in general work with hubs now? Maybe it already did. Yeah, I think it should. It should work with hubs, but tinyusb has a hard-coded limit on the number of hubs. You just want to make sure that that's higher than you need. Wow. You know, it's Friday when. So what's failing us? It looks right. I walked through it. I explained it. What could be wrong? Maybe my data length is wrong, so I'm not setting the buffer. Is my test for, do I put it in the buffer wrong? That could be it. Control failed. It's not that. Out transaction. It could be. Well, I guess setup is going to be the first problem. USB setup. And then, yeah, the RX buffer. Let's just double check that I'm filling the RX buffer like I think I was. If index is less than the buffer length. That looks right to me. Okay, last one, and then we'll stop the stream. That might be a Monday problem too. I think so, probably. Just like this Discord thing. What is it saying? New audio device detected. Don't switch. Thank you. You don't realize that you're on my stream. Sawdustin says, I could never live stream my programming sessions. There would be too much profanity. Yeah, well, I just pull my hair out. And actually, there is cussing on Adafruit streams once in a while, if you watch enough of them. So it's not the end of the world if I let something slip. But generally, I try to stay family friendly, especially because I have a 2-year-old. He doesn't watch this, but getting myself out of the habit of doing that. Although probably driving is going to be the problem. Oh, I think I thought. Yep, setup transaction failed. So why is that? Actual length. Wait. Transfer. Wait handshake. It's probably blank, right? But we think we're getting data. And it should be that. Index is less than. Oh, this is the problem. We are indexing before. We want to index after. Otherwise, we're putting it in the wrong place. All right, I think I found it. There's been some funny things that I've said around the 2-year-old, who's almost 3. He's 3 next month. I said, "What the heck? What the heck? What the heck?" And then I hear, "What the heck?" We were leaving the house and I was, "Goodbye, I love you," yelling up to my wife, and he just followed me on that too. All right, how's it look? In transaction failed. So setup didn't fail, but the next one did. That's progress. I got a little more time. In transaction failed because receive PID is wrong. Because we're in receive packet in handshake. Receive length. I kind of don't care how slow I am printing. Interesting that it checks the IRQ. Greater than or equal to 0. I wonder what the value is. Because and handshake. Okay. All right, well, I know I'm over time, but I don't have to leave quite yet. Sorry to DCD in advance if I don't put time codes in today and do it Monday. I'm in the zone. I've been in the USB zone all day doing this stuff. So I definitely need to commit it and push it and let Tack know that this is what I've been working on. Because his Monday is before my Monday. Okay. Receive length. Empty. I'm having to me it seems like it's working. I'm having printing from 2 cores problems. Device attached, full speed, get descriptor. I wonder if it works. Or this is delaying me. Let's just take them out and see what happens. The prints out. Or in failed receive. Make it smaller. Does tinyusb use interrupts? This code does not, but usually it does. So usually interrupts are done when the USB hardware has received packets, and then it gets queued into a FIFO that tinyusb maintains, that then runs in the main thread kind of task. That's not in an interrupt. But in this case, kind of like the second core is acting as the USB hardware, so it's all just like wait around for start a frame and then do the whole frame and then call the interrupt handler from there that then queues stuff into a queue that then the core 0 runs. So it's not really interrupts in this case. Yeah, last try. We'll see. Well, yeah, last try, and we'll finish up. I do need to get it committed because I want to be able to link tack to it. Yeah, receive length. I'm just doing mixed printing and it's not helping me. It's happening, but it's not. The only other trick I can think of is the old while true. Have you done this trick? I know I said that was the last thing. So, because I'm not starting it with a debugger, I basically run it here, copy it over, and like hang the core, hang the second core where it gets here. And my openocd is running still, and now I can wait for it to come up. And then arm. And now I'm in transaction line 548, where my while true is, and I can take a look at receive length, which is -1. Expected PID is 75 and a received PID 75. But receive length is -1. So if I go to receive packet and handshake, length is 0. Let's just do the same trick. This may not help me because I might be one step that. Yeah, it's like a breakpoint. But it's a breakpoint that works when your debugger is not attached yet, because you're literally just spinning. I don't know if we'll get this far. But it should be the first failure, because I think the first thing is doing the wait handshake, and then the second thing is doing the receive packet and handshake. Serial console setup. Yeah, so the first core did the same thing. The second core is now in receive packet and handshake 231. So it's in here. Wait packet length 0. Length 0. Bus wait packet. But we're printing here. And we're printing CRC failed. Do you think that's it? It's possible index is 0. And it went straight through? I don't know. I gotta Monday it. Monday. Okay, let me go to the camera, fix up, and then I will push it. If you want to follow along, I'll put this code will go into github.com/tannewt/pio, pico, pio, USB, or whatever it's called. So thank you, everybody, for following along. If I missed... sorry for anybody I missed on YouTube. This has been another deep dive. Welcome to the weeds of USB host debugging. My name is Scott. I work on CircuitPython for Adafruit. Now I want to put the Salier on it because I can twiddle some pins to figure out what's happening and look at the data lines with the Salier. I think that's what I'll do on Monday. And then I can see what's on the wire. Thank you, everybody, for hanging out. If you want to support me, go to adafruit.com. If you want to join the Discord, it's adafru.it/discord. I just looked out the window, and now it's raining, so I may get rained on the way home. Thank you all. Preemptive thanks to DCD, who usually takes timecodes. And thanks for all for hanging out. I'm excited for more people to get fruit jams, but I'm hoping that they'll be reliable by the time they're in your hand. So I'm working on it. Thanks, everybody. Have a great weekend. I'll see you next week. And then Foamy Guy will do the 3 weeks after that. So preemptive thanks for Foamy Guy as well.